Example 12, we're given that the sine of t is negative 2/5. T is between 3 pi over 2 and 2 pi, meaning that's going to be in the fourth quadrant. We want to find the secant of t. So here we're not looking for every other possible trigonometric function. We're looking for just the secant, given that we know what the sine is. So again, I know that the sine of t is y over r, so y over r should have a negative 2/5 ratio. And if I'm drawing it in quadrant 4, that means that the y value is going to be negative 2, of course, because the r value has to be positive. And I could use the Pythagorean theorem to find out what x is. And I show the work there, and I get that the x is the square root of 21. And the reason why I want to know that is, depending on how you go about doing it, like for instance, my mind's kind of set because, I learned sine, cosine, and tangent so well that anytime I see secant come up, I know it's a reciprocal of cosine, so I just find out what cosine is and then go from there and do whatever I need to do. But even with that, I could even take the step right here and say, well, if cosine is going to be x over r, which would be the square root of 21 over 5, that means that the secant would have to be r over x, which would be 5 over the square root of 21, which again, that's a good enough answer for me. That's a good enough answer for web work. For checking your work with textbook answers or looking at standardized tests where there might be multiple choice items, they'll tend to rationalize that denominator and tell you it's 5 square root of 21 over 21. And example 13, find the 6 trigonometric functions at t given that the terminal ray of angle t passes through 2, -7. So there's 2, -7, and my terminal ray passes through it, which means like when I put these things down, these are ratios. I don't know if the actual sides are 2 and -7. I know it passes through 2, -7, but for all I know, um, it could be going through 4, -14, or something along those lines. The actual length of the figure. So I could be stopping there. So, just because we put these ratios down, that's going to be important to note for an example that I'm going to talk about later. These numbers I'm using, the 2 and -7, are ratio numbers. They're not necessarily actual values that are on a particular right triangle. So, but I do get r is the square root of 53. So I know what my x is. I know what an x is. I know what a y is, and I know the r value associated with those two. So I can start figuring out what the trig functions are. The sine of t is going to be y over r, so -7 over the square root of 53. The cosine of t is going to be x over r, so 2 over the square root of 53. And of course, the tangent is going to be y over x, which is a -7/2. As far as the other three go, I'm just going to take the reciprocals of these three. So cosecant is going to be the reciprocal of sine, so it's going to be negative square root of 53 over 7. The secant is going to be square root of 53 over 2 because I just took a reciprocal of cosine. And cotangent is going to be a -2/7 because all I'm doing is a reciprocal of tangent. And again, for the sine and cosine, the textbooks and multiple choice items, you would tend to see any answers presented in rational form. So if I rationalize the denominator, that's what I would get. So again, I don't care if you rationalize the denominator for my quizzes or tests. It's not important to me. Also, and WebWorks certainly doesn't care either. If as long as you're putting the code, the things in structurally correct, it'll calculate the right value for you. It's just like as I said, textbook answer keys as well as items that you would see on a multiple choice item on a test. They're going to have they're going to be rationalized. You're not going to necessarily have any radicals and denominators.